Okay, so good day, grade 8 math sci students. So for our second lesson, the third quarter, we're going to be discussing about, or we will be discussing about areas of triangles. So we will determine 5 different types of areas, okay, 5 different ways to solve for the area of a triangle. So for starters, let's have this cute problem right here. So we have here Hero of Alexandria, the discoverer of Heron's formula. An intuitive formula for finding the area of a triangle has an owl. So let's say, for example, this is Heron's or Hero's owl. Okay, so he locked his owl in a triangular cage, so we need to answer the question that we have here. So given sides MI, IN, and NN, has side measurements 21 centimeters, 23 centimeters, and 27 centimeters respectively. What is the area of the triangular cage? So we want to know the area of triangle MIN. So to do that, we have to write the three sides. So side A, okay, so that could be MI, so that's 21 centimeters. Side B, so this could be side IN, so this is 23 centimeters. And side C, this could be side MN, so this is 27 centimeters. So using Heron's formula, we can solve for the area of this triangle. Okay, so Heron's formula, as you will see later in this video, is given by this formula. A is equal to the square root of S times S minus the first side, which is A, times S minus the second side, which is B, and S minus the third side, which is C, wherein the value of S, or we call that the semi-perimeter, is equal to A plus B plus C all over 2. Okay, so we're going to first have to solve for the value of S in order for us to solve for the area of the triangle. Okay, so we have here S, or the semi-perimeter of this triangle that we have here, is equal to 21 plus 23 plus 27 divided by 2. Okay, so let's check that on our calculator. So we have 21 plus 23 plus 27 divided by 2. So we get 35.5. Okay, so that's the value of our S. Okay, so A now, the area of our triangle becomes 35.5. Okay, so that becomes 35.5 times 35.5 minus 21, which is the value of our A, times 35.5 minus the value of B, which is 23, times 35.5 minus the value of C, which is 27. Okay, and now we can solve for the area because all of these givens are constants. Okay, so solving for the area of the triangle, we have here 35.5. Okay, so we can just write it ahead on the calculator. 35.5 times 35.5 minus 21. Okay, so we're just doing it all neatly here in the calculator, or straight to the point. Okay, and then multiplied by 35.5 minus 27. Okay, so we get 875,000. Okay, 875,075 all over 16. Okay, we need to get the square root of this fraction that we have here. And the square root of this fraction is equal to 233.86. So there you go. So this is the area of triangle MIN. Okay, or the two-dimensional triangle where the owl is caged. Okay, so we have here 233.86, okay, squared centimeters. Okay, squared centimeters. So this is the area. Okay, this is the area of the cage where the owl has been caged. Only the two-dimensional surface of it, using Heron's formula. Okay, so there are other ways of solving the area. The most conventional and the most traditional way of solving the area of a triangle would be using the A is equal to 1/2 base times height, where you're given the base. Okay, so for this figure, we have your triangle TRI, and our base is this letter A there. Okay, so that's our base, and our height is given small a, the lowercase a, so that's the base, and the lowercase h, so that's the height. So this is the normal way or traditional way of finding the area of a triangle. Given, for example, we have here a base of a triangle. Let's say it's 4 centimeters and its height is equal to 6 centimeters. We want to know its area. Okay, so we want to know the area of this triangle. So we just simply use this formula. Okay, so this has been taught to you guys in elementary years. Okay, so very simple. Okay, so therefore we have here 1/2 times 24, and therefore the area of the triangle is equal to 12 squared centimeters. Okay, there you go. Okay, so let's go to the second one. So using this one, a typically more advanced formula we have here. So we're going to use the sine function. Okay, so when we're using the sine function, one automatically comes to mind the trigonometric functions, or trigonometry comes to mind when we're seeing the sine function. Well, for this one, yes, there's going to be a bit of trigonometry, but we're just using the sine function as a way to express the angle measurement that's been given to us, because we're going to use only this formula if we have two given side measurements. Okay, so we have two given side measurements, and also we only have one given angle. Okay, we have one given angle. Okay, let's say for example you're being asked to find the area of a triangle. Area of triangle, let's say triangle ABC, given that side AB is equal to 15 centimeters, side BC is equal to 17 centimeters, and angle so let's write that A, B, C. So we have AB, and then we have BC. So we have here that angle B, angle B measures, let's say 47 degrees. So how can you compute for the area of this triangle given only this information? Two side measurements and an angle. So we can use the formula for finding the area of a triangle using the sine function. So this gives us A is equal to 1/2. Where your A and B, those are the two side measurements that you have, and sine C. But since for our problem we have here a sine B, so we can say that A is equal to 1/2 AC sine B. Where sine B, where B here, the capital B or the uppercase B, is your angle measurement. So we have here 1/2 times A, which is 15, times C, which is 17. And then sine B, which is 47 degrees. So let's try to compute this one using our calculator. So we have here 15 times 17, we're going to get 255. 255 all over 2 multiplied by sine 47. So we can evaluate first 255 divided by 2. We get 127.5. And then we multiply that to sine 47 degrees. So we just simply input on your calculator sine, sine, and then 47 degrees. And you get an answer of 93.25. 93.25 squared centimeters. So this is the area of triangle ABC. 93.27. Oh no. 93.25. 93.25 squared centimeters. This is the area of our triangle, given that we have AB is equal to 15 centimeters, BC is equal to 17 centimeters, and angle B is equal to 47 degrees. So again, these side measurements and the angles vary depending on the given that was given to you. So there you go. And it's much more neat if you draw the figure itself, so that when you solve for the area, it's much easier. So for the third one, so we have another another method for solving for the area of a triangle. So this also using the sine function, but for this one, we're only given one side. Okay, so we're only given, okay, so the given information that we have here. For the second formula, we're given 2 side measurements, but for this one, we're only given 1 side measurement. Okay, so that's A. So A, for example, can be, let's say, 10 meters. Okay, and we have here 2 angles, angle B and angle C. Okay, let's say angle B measures 27 degrees and angle C measures let's say 64 degrees. Okay, we want to solve for the area of triangle ABC. Okay, so let's try to draw triangle ABC here. Okay, triangle ABC. Okay, so we have here angle B is 27 degrees, angle C is 64 degrees, and we have here an angle that we don't know. Okay, but we have here a side measurement that we do know, which is 10 meters. Okay, so using the angle side angle triangle congruence postulate, so that's one of the derivations of this formula, the sine function formula for the second formula for the sine function for finding the area of a triangle. But yeah, so that's one of the derivations of the formula using the ASA triangle congruence postulate, the one that we've already discussed during the second quarter. So once you use that triangle congruence postulate, we get this formula right here. So A is equal to A squared. So this is the measurement of the side that we're given, multiplied by sine B, and then multiplied by sine C, all over 2 times sine quantity B plus C. Or in other words, we have to add the measurement of the 2 angles. Okay, so we need to find the area of this triangle. Okay, so what's the area of triangle ABC? Okay, so using this formula, let's try to find that. Okay, so A is equal to, so what's the value of our A? So that's 10 squared. Okay, 10 squared times sine B. Our angle B measures 27 degrees, so we write there 27. And then sine C, the value of our C is 64 degrees, so we write there 64. All over 2 multiplied by sine, and then we add the 2 angle measurements that were given, 27 and 64. So 27 plus 64. Okay, so let's try to solve. So this gives us 100. Okay, so let's try to simplify first everything before we input this entire function in our calculator. Okay, so sine 27 multiplied by sine 64 all over 2. Sine, okay, 27 plus 64, we get 91. Okay, times 91. Okay, so we can input this entire function in our scientific calculator. If you have a 2-liner scientific calculator, so it's best that you do the numerator first, then the denominator after. So you write the answer first on the paper, and then after that you solve for the denominator, and then you write the answer on your paper, and then that's the time that you divide. But if you have a 3-liner calculator, so it's a lot more easier, a lot more efficient, you can solve it right ahead. Okay, so 100 times sine, okay, 27. Okay, sine 27 multiplied by sine 64. Okay, sine 64. Okay, all over 2 times sine, what's that? Sine, when we added 27 plus 64. Okay, wait, 27 plus 64. Okay, so that's going to give us 91. Okay, so 2 times sine 91 degrees. Okay, so if we input all of that on our calculator, we're going to get 20. Okay, 20.41. Okay, so therefore that's the area of our given triangle. Okay, so the area of triangle ABC is 20.41 squared meters. Okay, so that's the answer, 20.41 squared meters. Okay, so we're going to move forward with the fourth one. Okay, after this one. Okay, so the Heron's formula.